The ideal gas law. Ideal gas law is PV equals nRT, or Pivnert. P is pressure, it has to be in the units of ATM. V is volume, and it has to be in the units of liters. N is number of moles. So if they give you grams, that's related to moles, and so you can plug grams in and then convert. R is the gas law constant. It's 0.0821 liters times atmospheres over moles times Kelvin. So it would look like so. Or if we're putting the gas law constant R in the bottom of an equation, then the number always goes wherever R is. And it'll look like that. You'll see what I mean by those two examples when we get into the problems. But notice that the number always goes with liters and atmospheres, and mole Kelvin always goes opposite of the number and liters and atmospheres. T is temperature, and just like all of our equations, it must be in Kelvin. So we know we're going to be using Pivnert, or the ideal gas law equation, because we have moles, one pressure, one volume, one temperature. We have one of everything, and there's moles in the problem. So just like before, we're going to label all of our pieces. And make sure you convert your temperature to Kelvin. Then we're going to write our equation. It says we're looking for moles. Circle your variable and rearrange. To get N by itself, we're going to have to divide by RT. So N is equal to PV over RT. Now I can plug in all my variables. I plug in my pressure. With units, I plug in my volume. I plug in my R. My R has to go in the bottom. And my R, because it has units on top and bottom, is going to have to go in its separate box. Again, R is on the bottom, so that's where the number is going to go. That's where my liters and atmospheres go. Opposite of liters and atmospheres is mole Kelvin. So again, we put the number on the bottom with liters and atmospheres because R was on the bottom. Temperature needs to be on bottom. I can put that anywhere on the bottom. And now I'm going to start crossing out my units. ATM cancel. Kelvin cancel. But that's all. Notice my milliliters and liters don't cancel because they have to have liters. So 1,000 milliliters is 1 liter. So now millis cancel, liters cancel. I'm left with moles. So now I can plug it into the calculator. Again, make sure that you pause the video and plug it in. You should get that when you plug it in, and we want 3 significant figures. So that first zeros don't count, so that's 1, 2, 3. So 0.0368 moles. Let's try one more together. Make sure we're good on how to plug in that R. First step, label all of our variables. We have 1 temperature, 1 pressure, 1 volume. We have moles, so we're using Pivnert. This time it says what is the pressure, so I'm looking for P. So I've got to get rid of V. And now I'm going to plug everything in. My R is on top this time, so my 0.0821 liters times atmosphere is on top, mole times Kelvin on bottom. Temperature on top. And volume on bottom. Cancel my units. I'm at ATM, but the problem says, what's your pressure in kPa? So I need one more step. 1 ATM is 101.3 kPa. ATM cancel. I'm left with kPa, which is what I want my answer in. So plug that into the calculator. You should get 5,006.67. Looking up, we need 2 sig figs because this has the least number. So I need this 0 to count, but not the ones after it. So normally I would just convert all the numbers afterwards to zeros. 50 is not the same as 5,000, so you have to convert to scientific notation. That's 1, 2, 3. So 5.0 times 10 to the third kPa. I'm going to pause the video and try this one on your own. Restart when you have a final answer. So looking at this problem, you should have gotten 0.057 moles. Make sure that you converted your ATM or your millimeters of mercury to ATM, and you converted your milliliters to liters. So make sure that you have these final 2 steps if you didn't get that. If you didn't get this, you can pause it and keep looking at it. Otherwise, try this last one on your own. Remember that because they gave you grams, grams are related to moles. So you're going to need to plug that in for moles and then convert it to moles in the equation. So go ahead and try solving this one on your own. Restart when you have an answer. So on this one, just to make sure that we were all clear, we plugged in our 36 grams for N, but 36 grams is not moles. It's just related to moles. So I convert my grams to moles. There's 4 grams of helium in every 1 mole of helium from the periodic table. And then everything else is just like what we've been doing. I have ATM. They want their pressure in ATM. And so you should have gotten 42 in the correct number of sig figs. As far as answers, D is the best answer.